So we're going to be talking about successful code sharing principles for mobile development. Is everyone in here doing Salmon or different mobile technologies? Any React Native or Native Script? So a bunch of different ways for us to build mobile apps. And I'm here to talk about how we can do this in a more proper manner using Salmon. So I've been in a bunch of different Salmon projects all over the world, and I see a few common mistakes, and I've learned a lot during the times on those projects. So I will be sharing a little bit about how we can improve how we build these apps by applying a few good principles. Before that, though, I am Filip Ekberg. I'm a Microsoft and Salmon MVP. That pretty much means that I go around to conferences and talk about these technologies. Don't really mean that I know how to actually build the apps. So I do my best to learn about all these technologies, and I love talking about them. And what I want to do is that if you snap a photo and ping me on Twitter, you have my Twitter handle there, I'll give you a free copy of my book, C# Smorgasbord. All right? So successful code sharing principles. What I want to talk about is some really fundamental and easy ways for us to build better mobile apps. We'll apply some, the principles that we learned back in school or when we started programming. We'll try and reapply that in our Salmon applications. Because it's really hard for us sometimes to get this done correctly in a mobile environment, because fundamentally these platforms are totally different. And if you come from a Java background or a Swift background, you've seen how you do it on those native platforms. But when you start introducing more platforms, everything becomes a little bit more interesting. So I like to talk about this from the perspective of unsuccessful code sharing principles. Because I've been in plenty of projects where we've kind of failed doing code sharing properly. And I don't know if I'm the common denominator, but I've been in all these projects that potentially they could have better code. And I've learned from that, and I'd like to share a few things that I think is interesting. And this is in Salmon. Is everyone here familiar with Salmon? This is not an introduction to Salmon. I will show some fundamental parts in building apps using Salmon and how we can improve those apps. And I will talk about kind of the future of how you would build an app maybe in 6 months or a year from now, and kind of what my goal is when I apply these principles in these apps. So the idea of Salmon is that we can achieve really good code across different platforms that are totally different. So if I've got a Tyson Samsung TV that's a smart TV at home, if I've got a HoloLens, if I've got this Surface Hub, or if I've got a Surface Book or a iPad or an Android tablet or a smartwatch, I can share the same code across all those different platforms. But the interesting thing here is that they're totally different. It's different ways of interacting with the platform. But things like, how do I store data across these platforms? That's probably the same. If they're hooked up to internet, like I can use the HTTP client. And things like that, I want to talk about how we can make it easier for us to introduce code that's shared across all these different platforms, even if they're totally different. So now when we talk about code sharing, the total idea here is that we have this really enormous shared C# application layer. And you've probably all seen this graphic before, where we talk about the perfect world. We have 3 different pillars. We might have iOS, Android, and if you have a boss that uses Windows Phone, you probably have to build a Windows Phone app. Otherwise, no one really focuses on building Windows Phone apps anymore. But what happens here is that the idea is that we have C# code across all the platforms. So we divide these into boxes. We have a small layer that's an iOS project, an Android project, and then we have a lot of code that's being shared. What I normally see, though, is that it's really hard to share 100% of code across platforms that are totally different. So what happens is that we pretty much end up with something like this here. We have a very small shared code layer, and then if we have a totally awesome iOS developer, what happens is that the iOS layer kind of tends to grow a lot because they like to do everything natively, but in C# using Salmon. So what happens is that we try to build the apps like you would build them when you build a native app, but you do it in Salmon, which kind of defeats the purpose. So the idea is that we try to minimize the amount of code that we have in these in the platform-specific layers and add that to the shared application layer instead. So I'd like to have a look at kind of a current state. What you would get when you start Visual Studio for Mac and you create a new project, you get a really nice project template. And that's kind of their idea of having like a perfect goal or the holy grail of what the app structure would look like. But if they did it perfectly, I would probably not bring it up as an example. So what we have here is an application that's available for Android and iOS. And when I create this solution here, I get three different things. I get a shared project. A shared project is a way for me to create C# classes, interfaces, and services, and repositories, and all that, and have that in one place. But the difference between a shared project and any normal project, like a class library in C#, is that all the files that I have in here are going to be brought into the project that I compile and be compiled as a part of that. That means that if we go into this file here called app.cs, for instance, which is in this demo1 shared project, you can see here that there's no references or anything in this project, and if I would try to compile this, nothing would happen. Because what happens is that when the C# compiler sees this project, it'll bring in this app class into the project that I compile, which would be the iOS or Android app, and it compiles that as a part of that project. So when it does that, we can do things like we can say, well, if it's iOS, I want you to compile this line of code here. Otherwise, I want you to compile this part of code here. So I'll cover more about why you would not want to do that in just a moment. But what we can see here with this project is that, well, we are trying to follow some really best practices. So they're trying to set this up with the same principles that if you see in Salmon forums. So they have this idea of there's one app file that controls the states in our app, or setting everything up like dependency injection and inversion of control. And then we have something called view models. Now, the view models and the idea of a view model is that we have logic that concerns a certain view in that particular file. So for instance, if I have an iOS app or an Android app, and both of them have a login screen, both of them probably require the username and password, probably have the same requirements for the password, and something's going to happen when you click login. Like the idea of that same logic happening on all the different platforms will be the same, right? It doesn't matter if it's on iOS or Android device. So the idea is that we bring all that UI logic into one place, like a view model, and we add that to our project. So now what happens is that we have a reference to that here in our Android project, and I'll just start this here, and I'll show you what this app looks like. So the idea here is that we have this kind of big project for Android. And it looks like an Android app because Salmon is native. And all the times that I've talked about Salmon in the past, one of the things that I reiterate is that everything is native. All the controls are as fast as you would get if you built this in Java. Now, what we can see in here is that we have this main screen here. And you can see here that it says sign in as Filip here. Now, what it's doing is that it's in the background, it's using some service, and it's using some patterns to allow me to share instances across different screens. So what we didn't see here was that in the splash, it sets up some value, which I can then use somewhere else in the app. So that's the idea of separating concerns in my app. So what I want to be able to do is that I want to be able to use the same kind of data across the different screens in my app. And if we just go into this here before we look at the code, we'll see here that we can click around in this Salmon application, and it looks like an Android app. So what they've done here is that all the things for like the data store and all the information, that's stored inside this shared project. And how we build up all those different pieces is stored in this shared code. But the problem here is that we have a lot of files in our Android project. We have things like activities, which is a way for us to set up the view files on Android. And if we have a look at this splash screen, we'll see here that, just turn this off so it makes it easier to look at. We can see here that, well, it's requesting a few services using a few patterns that I'll talk about later on. But we can also see here that, well, it's doing a bit of logic in here. And we want to build applications using better practices. And one of the reasons that we want to do that is because we want to build apps that are more maintainable and probably more testable, right? So even if this small part here shows us that, well, it's just checking if we're logged in. And if we're not logged in, we'll do this. If we're logged in, we'll go somewhere else. Now, this is a very simple example. But what I see happen quite often is that, well, it's just this part of the code here. So how about I'll just add a few more lines. Let's add something to the database, right? And then do something with Google Analytics, right? So what happens here is that if we start adding more things into the platform-specific layers, we'll start having more and more code inside the wrong places. So we'll start to look at a few practices that we can go by to make this a lot better. So if we use this as a current state, so this is like a really good example because it's already very good, but they've still done a few things that I think they could do better, such as I wouldn't do things like the view logic inside one of the activities, because the same logic applies to both iOS and Android. So just play with the thought that those 6 lines, we could bring them into a view model or somewhere else that's shared across both of the platforms, and then we could just add a lot of logic to that if we need to, right? But then you ask yourself, well, how do I transition to a new intent from one of the view controllers? Sorry. Oh, excuse me. Losing my voice. Whew. That's not good. Whew, excuse me. There we go. So let's head back to the slides. All right. So if we have this as a current state, we can see that it's really a good example, right? Because they've tried to do all the right things, but then they fail in some places, like still having view logic inside our activities. So why is code sharing so hard? Well, as I mentioned earlier, they're fundamentally different, right? So iOS is totally different to Android, and Windows is totally different to the other ones. Whoa, that's never happened. Sorry. So I said in my talk earlier this week that I'm starting to calm down with something. So if I fall off the stage and something happens, just slowly walk out of the room and put a green thing in the box. Just forget you were ever here, right? Nah, joking. So code sharing is so hard because their platforms are totally different, right? iOS is different to Android. We have different paradigms of both the different platforms. Android uses activities, iOS uses view controllers, and so forth. And it's not only that they have that they're fundamentally different, but different form factors. Everything from the Surface Hub. Has everyone seen the Surface Hub? They got one over at the Redify office. It's really nice. It's this big 80-inch screen. It's like a smart whiteboard. And we've got the HoloLens and so forth. So the idea is that we can target all these different platforms with the same code. And if we apply better practices, it'll be easier for us to target new platforms. Most of the times, when we look at things like the Android, we want to build a UI that works on all the different Android devices. Platform fragmentation and OS fragmentation on Android is really silly. Like, I don't know if we have any native Android developers here that have been around for a long time. Like, there's so many different form factors. And the API levels and the different things that you can or cannot do on those different platforms. So we want to choose like a minimum version that we want to target and just stick with that. And sometimes it is OK to break out of the box. If I'm working with shared code and I want to do something very platform specific, that's all right. We can totally do that. And we'll look at some example on how we can do that properly. Sometimes, when we're building applications, and this applies to like every different software product that we have out there, it feels like we know where to start, we know where we want to end, we hit a few roadblocks along the way, and it feels like this maze we need to go through. This applies to pretty much every different software project, right? If we're working agile, there's a few changes along the way that makes it harder for us to reach the goal sometimes. But I feel like if we add the parameter of having all these different platforms, it kind of ends up being this instead, right? So we want to target, we'll build this thing on Android, and we want to build that thing on iOS. And one of the things I find happening is that, I'm starting off a new project, and we start off building the Android app, and then you build all the UI, you build all the logic, and then in the end of the project, someone says, well, let's just compile that for iOS. Doesn't really work like that. We need to get all the parameters in the start, and it is amazing that a lot of the times when I build Salmon apps, I do feel like this. I want to scream at my code. I want to go back to the start of the maze and just redo everything and hope for a better world, right? I want to hope for everything to be better the second time I do it. Then I restart and I do the same mistakes again, or different mistakes. So how do we solve this? How do we make our code better? How do we approach this? So we've looked at code that looks pretty good, and a lot of us probably work in code bases that are a lot worse, in a lot worse state than what we saw from that out-of-the-box example. Well, one of the ways that we solve this is by introducing abstractions. Now, an easy way for me to score a lot of green votes would be to jump around here like Steve Ballmer and scream abstractions, abstractions, abstractions. But since I'm coming down with a cold or something, I'm not going to do that. But you're welcome to put a green vote in the box anyways. All joking aside, so how do we solve this? Well, we can introduce interfaces. We can introduce abstract classes and then make sure that we use that interface across the portable class library, or we use that inside our shared code. So then what happens when we try that? So I've done that as well, and what happens is that we look at that shared code, and all of a sudden someone tries to do platform-specific code in our shared libraries. It kind of defeats the purpose. So what do we mean by doing shared, platform-specific code in those shared layers? Well, the code that we just saw inside this project here, let me just show that again. So we saw here that we can say, well, in this app, when we start off this entire app, this class is initialized from both Android and iOS. And we're saying here that, well, if this runs on iOS, I want you to do this part of code here. What's interesting here is that they're simply saying that, well, I want an iMessage dialog to be an iOS message dialog. For Android, I want that to be a Droid message dialog. Actually, they're saying that if it's iOS, I want that to be a particular iOS message dialog, and for Windows Phone and HoloLens and all the other platforms as well, I want this to be the Droid message dialog. Right? So this is kind of where we're leaking platform-specific code inside our shared code. And that's not good. So that's one of the things that I don't like about their out-of-the-box examples. It's fine to want to have platform-specific code, but don't add that into the shared logic. So how would we properly structure that? Well, we can introduce layers in our apps. We've all looked at all the layered structures over the years, and I like layers. So what we can do, if you start from the bottom, we introduce a portable class library. I like to think about that as where to put the code that I would share across Xamarin apps, desktop apps, ASP.NET apps, and so forth. So what normally happens is that in my projects, what we do is that all our PCLs, services, interfaces, sometimes maybe repositories, depends on how abstract they are, we put that into NuGet packages. And then we share that internally on an internal NuGet server with all the different teams working on .NET. So that means that if I need to talk to our backend, and I don't want to introduce all the different things that they've had to do to make that work, I can just bring in that NuGet package. Right? And then one step above that, we're pretty much inside the code that I write in my solution that I have here. So we start looking at the shared logic, which could be common implementations for interfaces. So we'll look at an example of that as well. It could be that I have for instance, an iAccount service or an iSomething repository or an iService living inside a PCL. It defines a common contract that this is how you work with this thing. And then for iOS and Android, the implementation is a little bit different. But if the implementation would be similar on my Xamarin apps, but different on ASP.NET, I can have a shared project in my Xamarin app that implements that for both iOS and Android in the same manner. And then one step above that, we have the shared UI. Now, don't be scared of doing shared UI. I'm not just talking about doing the same buttons and inputs. It could be the view models, right? View models like view logic. So we could say, if you click the button, this happens. That could be the same across iOS and Android. Then, of course, we have the native implementations. So I like to think about this as growing the further down you go. So we want to have a lot of PCLs, a lot of code shared coming in from NuGet, a lot of code in shared logic, and then, of course, we need view models, and then small native layers. But I'm not saying that more layers is necessarily better. We don't want to end up having like a microservice solution with 400 projects just to build a simple iOS and Android app. That's not what anyone wants. And there are so many patterns out there that sometimes it's really hard to know which one to choose. And I can say that we're going to use dependency injection and inversion of control, and we're going to use all these different awesome frameworks to solve all our problems. But we can throw a pattern at a problem and still have another problem. So we want to approach this with the correct patterns and make sure that we apply them correctly in our apps. Because we see here with the out-of-the-box example, they're using something called a service locator, which allows us to solve a particular problem. Especially if you're coming from an Android background, that kind of makes sense. Because the service locator is what you use on Android. So let's not just throw patterns at the problem, but let's introduce them where it makes sense. So ultimately, why do you want to do this? Well, we want to make sure that our code is more testable and maintainable. And hopefully, it's cheaper to build as well. The whole goal of Salmon is to build cheaper applications that perform as good or better than native apps, more code shared. And ultimately, we want to be able to target new platforms with as little code as possible. So as I mentioned earlier, how do we test this? So we have if you're an Android developer, you probably cringe a bit, even if you're a Salmon developer. Why would you unit test an activity? Well, you wouldn't. But then again, you shouldn't put view logic inside your view. I feel like this is like if you've done WinForms or WPF, this is like going into the code behind and adding a lot of view code. You just don't do it. So what I'm talking about is this part here. So if settings.is logged in, do this, otherwise do something else. So that part, we want to break that out. And we do that by decoupling the app, by bringing in things like view models and making sure that we have interfaces and services that supports that. And then we want to use frameworks to help us achieve those different goals. So one way to do this is throw more lines of code at the problem, which is always a good way to solve anything. So in this case here, we have a splash view model. And this one here takes an iSetting as a parameter to the constructor. So this here makes at least the view model a little bit more testable, if we want to test the view model. Then, of course, we're still doing something in here, but imagine that we were to inject a navigation as well. We could say that, well, we inject an iSetting as well as an iNavigator, and then we can check if it's doing the proper thing depending on the parameters that we set on our projects or in our properties. It makes it a little bit easier to test. Now, of course, this is a lot more code, and most of the Salmon projects that I've seen is that we start off with one platform and then we add the other one. And if you do that, you don't really think about these things until you go over to the next platform, because you want to be able to get your product to market as fast as possible. So what about platform-specific code? How do we do things like NFC? So funny story with NFC. I don't know if anyone saw the Apple keynote a while back. They've announced that you can now use the NFC chip on iOS. And you've been able to do that on Android since forever, pretty much. On Android, you can use both read and write NFC chips. So you can pretty much say that your phone is your Opal card, which is pretty great. So when Apple announced that as well, I'm like, yeah, that's awesome. Because now I can simulate a bank card and use that for bank transactions. Or I can simulate the Opal card. But what they've done is that they've done read-only, which means that you can only detect if there's an NFC tag. So they've kind of done one thing, but we're waiting for them to do it properly. So that means that our shared code that might be allowing us to do NFC needs to be changed for iOS, but it's a little bit different for Android. So this is a good scenario where we want to be totally different on iOS and Android. We might not even want to display certain things on Android or iOS, depending on if the feature is available or not. So how do we do this? Well, I showed you earlier that we can be specific in a shared manner. So in this case here, we have a way for us to retrieve a message from an HTTP response message. And the content here is going to be gzipped. And if it's gzipped, you have to manually decompress that on Android. But that's just automatic on iOS. So the way that we can do that is by, instead of introducing a lot of abstractions and interfaces and services, it's just this one line to say, well, if it's on Android, just run this different thing. You have to be careful, though. If you do this a lot, you'll end up in scenarios where it just grows and grows and grows and grows and grows. And then you certainly end up having your platform code inside your shared logic, and it's hard to test. It's hard to know what's happening. And we all probably know that if you have these compiler directives, sometimes the IDE doesn't notice that you've changed which project you're working on. It just becomes hard to work with. So another way that we can help with this is to introduce things like TinyIOC. So TinyIOC is an IOC container which allows us to register interfaces and implementations. And TinyIOC is just a small file that you bring into your project. It's available on GitHub. And it allows you to do things like I can register my account service. As an account service, I can introduce my iPreference service as a preference service and a cache as a singleton cache. Now, what's interesting here is that we can say that, well, give me the instance of an account service, which might have a dependency on a preference service, which might have a dependency on a cache. So they're all just automatically created and injected properly into the constructor of those different types. So it really helps us build better applications that are more decoupled. And what we can do here is go even further to say that, well, the account service is a little bit different on Android. So what I'll do is that I'll just register a different account service when we're in the Android project, and another one when I'm in the iOS project, and then in the shared code, it'll just pick the correct one. And then we can introduce something like the service locator to help us resolve these from the containers. So I can say here that, well, when I ask for the account service, go to the container that I've set up and ask for an iAccount service. Now, what happens here is that it's going to find the correct implementation for that particular platform. So let's just look at that and see what it looks like inside our code. So we saw that pretty quickly just recently that I did that here in this project. So I'm doing service locator.instance, because this is a singleton. I'm saying, well, I want you to register the iAccount service as an account service. Now, what's interesting with the account service is that it's, in fact, living inside my shared project. So I've got the same implementation for both iOS and Android. Now, we could play with the thought that, this iAccount service lived in a PCL that I bring in over NuGet, and then that's being used across a lot of different places inside the shared code that I bring into the project. But what I could do here is, of course, do different implementations per different platforms. And this here allows me to, for instance, as we saw in the splash, if we go down to Android, I can ask for the account service in here. And then I can tell this here to set something up. I want you to save some preferences for a certain account. So I have a demo account here with a dictionary of preferences. Sorry. And then what happens is that I can ask for the same one somewhere else in the app. So if we start the application, you'll see that it says sign in as Filip here. So if we go and have a look at that particular activity, which is the login activity, we can see here that the login activity is also asking for the account service. And then it's setting the button to that account name. So that's a way for us to share instances across different decoupled activities. All right. So we can do the same for iOS and Android, and we can do these things to make it easier for us to just get our implementations somewhere else. So this is just a way for us. And I'm not saying that the service locator is the best pattern out there. Because it's a singleton, and because we were saying that in here, we're kind of breaking a lot of other principles. So when I use the service locator, I feel like this. A lot of the times, what happens is that, well, you add the service locator, and you have this big method, and you're just asking for dependencies from other places, and you think, well, I'm using interfaces, so that's great. I'm decoupling my app. But what happens is that if you want to test that method, the person calling it, how would he know which interfaces to add to the service locator? That would be pretty hard. Now, the way that we solve that is by, of course, injecting the interfaces to the method instead, making it obvious for whoever calls it which one to use. Wow. And I tend to tell myself this. I don't want to repeat myself. Especially, I call myself an idiot all the time because I keep repeating myself. And one way to do that and to stop repeating myself is to stop repeating the UI. So how do we do that? Well, we could use Xamarin Forms. Is anyone using Xamarin Forms? No one? Hopefully, we'll be using a little bit of Xamarin Forms once we've done with this talk, if I can get through it without coughing all the time. Does anyone recognize this background? It's from Windows XP. Now, I'm not saying Windows XP was the best project, but was certainly a project that lived a long time. And I just love the background. So greenfield projects are interesting, because that means that we can choose whichever technologies that we want to do, right? We can choose the patterns and practices that are appropriate for our use case. Now, I've done a lot of mistakes in my career, and even if I'm in a greenfield project, I do certain decisions that make sense at the time, but then you regret that later on in the project because the requirements change. And that's not a difference here, right? But what we can do is to make it easier. We can think about how to avoid spaghetti code. Like, I wrote code last weekend that I think is bad now. So we learn from our mistakes all the time, and one way that we can approach this is by trying to just think about, how do I make this more testable? Like, if I'm going to go back in 2 weeks or 2 years, how do we make sure that this code is still solid? One of the dream scenarios is to be called up by your old workmates to say, like, your code is still in production, there's no problems, it's been running solid for 5 years, right? That's great. Probably a lot of security bugs in there, though, so they should probably restart the service. Anyway, so we want to avoid spaghetti code, and the way that we do that is by trying to abstract our solutions. Have an interface, do the implementation in one place, don't add a lot of platform-specific code in your shared projects. And what we can do is that we can try and introduce a little bit of Xamarin Forms. So we're adding one more thing to our bowl of spaghetti. So that would probably end up looking something like this here. So we have one way of doing this is by smacking in a little bit of Xamarin Forms, a little bit of shared UI. One of the views inside the app that we've looked at, it has 2 buttons. One says don't log in, and the other one says log in. The only difference between iOS and Android in that case would be that the buttons looks a bit different. On Android, they're a little bit more squarey, and on iOS, they're a little bit more nicer. So how about use Xamarin Forms for that? But then, you still have the platform-specific implementations that you might want to do per platform, but we can still do that. And in an ideal scenario, if we can introduce Xamarin Forms, which we can now do using something called Xamarin Forms Embedding, we'll end up having something that looks like this here. So ideally what happens is that only a small part in the apps are so platform-specific that we need to do the implementation in that layer, using nib files or storyboards for iOS, doing Android XML for Android. But only a very small portion of the code would be that important to be implemented in the native programming principles. Most of the times, we are good enough using Xamarin Forms. And now they've introduced something called Xamarin Forms Embedding, which lets us do things like we can use XAML to set up our Xamarin Forms page, and then we can just inject that into a native layer in Android or iOS. So that sounds pretty promising, and that also gives us the capabilities of using everything that we have available in Xamarin Forms, such as the messaging center, the dependency services, and things like event aggregation and inversion of control and all that. So how does this work? Well, it's simple. So I have a page here called main page. I say, well, start an instance of this main page, and then give me a fragment, or give me a view controller. This is pretty simple, and this allows us to do something like this here. We have an Android activity for the login screen, so when I click login, it brings us to this view here. And then on this view here, we have an Android fragment, which is, in fact, our Xamarin Forms page. That's pretty cool. And the same goes for iOS as well. So the UI is different, the UI is native, but we built the UI using the same code. So again, we're sharing more code. And I want to show you some code instead of just talking. So what I'll do is that we'll look at how this works. So what I have here is that it's pretty much the same structure. We've gone from having that baseline that we had before, same app. I just want to introduce something with Xamarin Forms. So I introduced this layer here called demo2.ui, which is a portable class library. So it has no reference to Android, no reference to iOS, has no idea about how to build a native app. So I don't have any native parts or anything in that project. It's all shared code. I think that's the best part about Xamarin Forms, is that it embraces the idea of sharing more code. It allows me to use the principles, like a dependency injection and interfaces and all that, and apply that in here to make sure that I don't write too much platform-specific code. So I have this My page here. And it's a simple page. This could have been SAML, but now I've done the code here in My page here. And it's going to show us a simple button. I click it. It just increments an integer. And then, if we look at the Android or iOS project, we see here that we have a tab bar on iOS. And what I'm doing here, it's a little bit more code on iOS than Android. And a few different reasons. It's because how this demo is set up. So I want to work out of the same examples that you would get when you start this project in Visual Studio for Mac, just to make it easier to follow along. So what I'm doing here is that I'm creating a new navigation page that has My page on it. And then I'm simply retrieving the view controller, or converting that Xamarin Forms page to a view controller, and then I'm just adding that to the collection of view controllers in my tab bar. So if we run this on iOS, we'll see what it looks like. It takes a while to start the simulator. So the idea here is that it's going to show us that we can combine Xamarin Forms and Xamarin Native. And I've done this in a few projects, and I think it's working out pretty well. So now we'll click Not Now here. You saw that was pretty quick to get into the app. I'll click About here at the bottom, which is in fact going to show us this Xamarin Forms page. So I can click that a lot, and it just increments that integer. So it still feels like a native application. I'm not a UI designer, so it doesn't look very beautiful. But imagine if you have a UX team working with you, and they can work with a SAML. Maybe they have some blend experience and done a lot of WPF in the past. They just have a blast building a beautiful app. So if we run the same one on Android, you'll notice a little bit difference in the speed. So I've done Xamarin Forms embedding even since before they announced it was a thing, because it's been working out pretty well on both iOS and Android, despite one thing. So now I click Not Now, and you see here that there's a little bit of delay. So initializing Xamarin Forms on Android takes a lot longer than it does on iOS. Click About here, and this looks like an Android app. Right? So the idea here is that we have the UI, it's shared, it's somewhere else. That's really good, and it's really easy for us to add this to our project. So if we just look at what this looks like on Android and the code, we'll see that we have this main activity. The activity itself allows us to get that fragment when you swap between those different tabs. Super simple. Pretty much the same code across iOS and Android. Right? So this here also allows us now to do things like using the messaging center, doing things like dependency services, and using all those tools like Prism. I don't know if anyone's using Prism in the past. It's a really great tool to allow us to do things like MVVM, which is pretty much the final things we're going to talk about. So we can do things like using the dependency service. So that's a little bit different way for us to register things for the IOC container. So we have this thing called the dependency service. It comes with Xamarin Forms. And what we can do is that we can say, we can use this assembly directive at the top here to say, well, this here contains the implementation for my account service. And then anywhere inside Xamarin Forms, we can say, well, give me the implementation of the account service. And that'll go out and find that inside our project. And even if we're working with a little bit of native and we're working with, Xamarin Forms, it'll all just work together. So we can use all these technologies and use them together, which is really good. So now you're probably thinking, well, if I have this login screen here, I click the login button, and we talked earlier about, well, you have this setting dot, it's logged in, and you want to transition to somewhere. How do you notify the OS or the app that you want to go somewhere else? Well, Xamarin Forms comes with something called the Messaging Center, which allows us to communicate between both Xamarin Forms pages and view models and so forth, as well as talking back to our native layers. So this is where it becomes really powerful. And this is where I see us succeeding more when we share code. So we can apply the common principles of just do abstractions and interfaces and PCLs and break everything up into smaller pieces. But when it comes to actually implementing this in the native layers and adding Xamarin Forms, this is where I think it becomes to make more sense. So an example of doing the messaging center is to say, well, I want to subscribe to this here in my native layer. So we can say, well, when the login completes, I want to go to this intent here. So imagine we had the setting.isLoggedIn. That could have raised this event, and then we can subscribe to that somewhere in the Android app. And then from within Xamarin Forms, we can say, well, distribute this using event aggregation. Just send it out to everyone that's listening that you're now logged in. It's really awesome. So let's look at some more code. Code speaks more than slides. So this allows us to, if we go in and have a look at this here, you'll see here that I've introduced something called a login view. The login view is supposed to just show us like a username, and then click login, and then you can come into the app. And I'm using a little bit of MVVM here. I'm doing data bindings. I'm saying, well, this is going to be bound to a property that I have in my view model. This here is going to be bound to a command. So this is now where we're starting to separate. We have a view over here, and then a view model, and then we have the activity. It's all getting more decoupled. Excuse me. So if we look at the view model, we can see here that, of course, there's a little bit of more code in here, but it's not too bad. One thing that you'll notice is that we were asking for our account service. What's really interesting here is that the account service, the interface lives in, let's say it lives in a PCL or it lives inside our Xamarin Forms project. Now, our Xamarin Forms project has no idea about Android or iOS. So what's pretty cool here is that I've registered the account service inside the actual native projects. So I've said that, well, I have this account service. So whenever it sees that, well, you're asking for an iAccount service, this thing here just lets it know that this is where you find an account service. It's pretty simple. And it's pretty good, because now I can use this inside Xamarin Forms, which has no idea about my native projects. I can work in a much more decoupled manner. And of course, you could write this even better to make it even more testable. And then what happens is that I'm using the messaging center to send out this login completed command. And you'll see here that I'm actually using a local version because there's been a bug lately in the one that they've distributed on NuGet. So I just pulled in an old one. It's on NuGet. Sorry, it's on GitHub. So that's all fine. Now, to initialize this on Android, we'll see that it requires a little bit more, not more code, but it requires us to do a few things. So I've got a fragment activity that allows me to display a fragment, which is how it works on Android. I'm starting off by initializing Xamarin Forms. And then I'm saying, well, I want you to subscribe for a certain event. The event happens on a login view model. When the login completes, we get the view model. And then we're going to do this. OK? And then I set up the login view. I give it a binding context, which lets me set up all the MVVM goodness. And then I transition to that fragment. So let's just look at what this looks like when we run the code. You'll see that so small changes to the code and introducing just these common practices that we've seen in Silverlight or WPF, it just makes it a little bit more fun to work with Xamarin apps, and it makes it easier for us to write more testable and maintainable code. So one of the problems that I've struggled with is that I tend to have projects where we have nib files and storyboards and Android XML, and then you have view controllers, and someone's built UI code inside the view controllers and inside the activities. It's sometimes just a big mess. So being able to just break out of that and just ignore it, go to a new, fresh Xamarin Forms PCL, and just build a little bit of the UI there instead, and introducing small pieces like the messaging center and the dependency service, it just makes it a little bit easier to work with even legacy code bases. Even if I would love to use this in a greenfield project, most of the times we don't work in new projects all the time. So I click sign in here. It takes a little bit of time to start up Xamarin Forms. It's quicker on iOS. I'll simply write Filip here. And what I'll do is that I'll set a breakpoint in here just to show you that it works. So this is inside my Android fragment. This here is inside Xamarin Forms. I'll click login here. We'll see that I got into this place here. And if I hover this here, we'll see that it in fact says that, I'll just show you like this. You'll see that it says Filip here. So it passed in the username that I entered into that text field. So I've used MVVM. I've done bindings. It raises a command. It distributes that using the messaging center. And it's storing that as well inside the account service, which it knew about using dependency services. So I'm introducing all these different tools to help me build these better apps. But there's still a few things that we could make better, right? I want to avoid doing this thing here at the bottom, so we can introduce tools to help us solve that as well. And just to show you that this looks the same on iOS, the code for iOS it should be identical. So we'll have a look at the login view controller. It's doing pretty much the same thing. It's listening for that event, and then it's navigating to that correct view. So let's run this and have a look. Click login. I'll write Filip, click login, and it just brings me into the app, which means that it works. And if I click About there at the bottom, it's using the same account service inside this view here, which is also using Xamarin Forms. So what's interesting here is that this About page is using, we talked about earlier that it used the My page that I added in the first demo. If we just look at that code now, inside this Xamarin Forms project, we have this My page. We can see here that this is also using the account service, and it's bringing out that name as well. So we got that passed through the native layers, and we use tools to help us make the code a bit more decoupled. Now, if you start using the messaging center and just racing events everywhere, like your coworkers are going to hate you because it's really hard to debug sometimes. It's like doing the old events in WinForms, right? So we don't want to do too much of that. So pretty much the final thing that I just want to talk a little bit more about is MVVM. MVVM allows us to kind of break up the app in a little bit of more structured manner. So we've got a view that represents what something looks like. Now, we can use MVVM even if we do native programming, like on Android and iOS. The view would be the Android XML or the storyboard. And then we have the view model, which is the shared view logic, which often uses data from a model which comes from a data store. Now, there's no one framework to rule them all. I like to use Prism, but there are other ones as well. We've got MVVM Lite, you've got Fresh MVVM, MVVM Cross, and there's a bunch of them out there to help us build these apps in a better manner, right? So the goal of one of these frameworks is to allow us to do things like navigation. Like, what happens if I click this button? I want to navigate somewhere. Navigation is different on the different platforms, but I don't really want to implement that myself. So we can use an MVVM framework to solve that for us. We can use an event aggregator, which is the same thing as the messaging center, to distribute messages between certain view models and between activities and view controls and so forth. And then, of course, dependency injection. So let's look at how we can do this with Prism. So I'm really liking doing dependency injection and being able to write more testable code. And I rather want to inject a lot of interfaces rather than having a service locator inside the method asking for that particular interface. So the final demo we have here is interesting because it's using Prism. And you'll see here that the view model is a little bit different. So it's actually now inheriting from something called a bindable base. And I'm injecting something called the iAccount service into this here, right? So you'd imagine that, well, you probably just create an instance of this in the Android project. But if we look at the code of how we set up this in the Android or iOS project, we'll see that that's actually not what's happening. So we'll check the same thing as we did before. So I'm calling load application. I'm setting up a new Salmon Forms application. I've replaced Salmon Forms.init with this thing here instead. And then what I'm doing is that I'm simply creating a new view here and create a fragment. I don't set the binding context or anything. So where does that come from? Well, it's magic. If we have a look at the app.saml.cs, this is the Prism application. It's like a Salmon Forms application, but a little bit of goodies added to it. So what it's actually doing here, it's using AutoFac internally. And the first thing that I'm doing is that I'm registering an instance of my iAccount service, which I'm getting out of the dependency service. So I'm combining these two services, really, just to grab that out from the native layers. And then I'm registering a navigation page and a login view. And when I register the login view here, it'll just do a lot of magic to know where to find the view controller, what things to inject. It knows that it's going to inject this iAccount service automatically. So that's really powerful. So what's happening now is that it knows that it's going to create this account service and pass that into this login view model, right? And then I'm using the messaging center to send data back again. But how does it know that it's using this particular view model? Well, if we take a look at the view that I've created, one of the things that I'm doing in here is to tell it to, I want you to automatically wire this up with the view model. So I've got a login view. When it finds this view here, it's going to say, well, I'm going to find a login view model to bind to this here. And it'll automatically set up the username and login command. So even more, I've reduced the amount of code that I have to write. In general, I don't have to set up the view model myself anymore. So if we just run this, we can see what it looks like. And I want to show you that it actually works. So we can go into two places. I want to show you the view model that we get this past here. And then inside the Android project, we'll put a breakpoint inside this messaging center subscribe here. So I'll run that. So now, some of the successful code sharing principles is just going back to the basics, doing things like inversion of control and dependency injection, and using the correct tools to help us solve those problems. So what I'll do here is I'll click sign in. I'll write to Filip, do login here. We see that we're now inside the login view model. Just get rid of this here. We can see here that we have an account service. There's actually an instance of that. We can hover over the username and see that it's bound that as well. So there's no magic. It's just, well, there is a bit of magic, but we don't see it. So I'm not doing anything manually to set that up. And now I'm going to release this breakpoint and go into the native layer. So now we're inside the Android project. And I can hover over the object here, and we can see that we have our login view model. So it's passing in Filip here inside the username, and we can use that inside Android as well. So what we're doing now is that we're taking our native Android project and introducing a little bit of Salmon Forms using Salmon Forms embedding, right? So you no longer really have to choose, do I want to do Salmon Forms or do I have to do Salmon Native? Well, you can combine the both in the best way possible. So I've tried to do this in a few projects, and it's been really successful. A lot of people that use the apps don't see any difference. Except on Android, there's a little bit of delay sometimes. So I've avoided doing it in really mission-critical parts of the apps. But once they fix those performance issues, like, you won't even notice a difference. And I think it's really powerful because, now we can write more testable code, and we can make sure that we adhere to those principles that we've all learned about. Right? So, the end goal is to write more testable, maintainable, and, more fun to work with apps. I don't know about you, but I personally like to write applications that I think are more fun. I want to focus on building features rather than working more with spaghetti code and solving the past week's coding issues, right? So we want to make sure that we feel a little bit more happy about our solutions. It's funny because when I choose this picture, I didn't even notice that there's a Mac, but you are required to still use a Mac when you're doing iOS development with Salmon. So we want to feel more like this. We want to be more happy when we're building Salmon. And I think that when I build Salmon apps and when I'm trying to adhere to these principles, I'm introducing things like a little bit of Salmon forums where it makes sense, doing a little bit of good code sharing practices, just makes it a bit more fun. And I don't want to be afraid of doing platform-specific code. So imagine if I do the NFC parts for Android, but not for iOS. It still makes sense to do most of the shared things in a shared layer. Abstract it out to interfaces. You might have something like read this thing from NFC in the contract, but you read from the NFC tag might still be shared across iOS and Android. So don't just build that into your Android project, but take the extra time and bring that into a PCL or a shared layer just to make sure that when it is available on iOS, it'll be easier for you to transition and add that into your iOS project as well. So hopefully we'll end up with a structure that looks a little bit more like this here. It's OK to have a little bit larger iOS project if that's what we want, and maybe a little bit larger Windows project. And people sometimes forget to do a little bit nicer things on Android. And then it's nice to have a shared UI layer as well, even if it's just the view models. You don't have to share the views, but at least try and share a little bit of view logic. What happens when we click the login button? That should be shared across the platforms. So just to wrap this up, I hope you've learned something about what you can do with Salmon Forms embedding and what you can do with better code principles and use Prism, and that you can combine these different principles to write applications that are a little bit more testable, a little bit more fun to work with, and ultimately, we want to go back to the basics and introduce things like dependency injection and inversion of control to make it easier and more fun to work with our apps. I want to thank you all for coming and listening to me. I'm really sorry about my voice, and I was trying my best to keep it up. If you want a copy of my book, please do ping me on Twitter or send me an email, and I'll be sticking around here for a while for questions. Thank you so much, and have a great Friday night.